Hello everyone. In this video, we're going to look at the problems from Module 1. And I'm going to emphasize this a lot. Make sure to try these problems on your own actively. So in order to learn new concepts, we need to be engaged. And one of the ways to engage ourselves mentally is to try a lot of problems. So I suggest you try these problems on your own. Then you can watch these videos to make sure your steps and your understanding of this concept are correct. And it is more than just procedural steps that we need to understand. We need to understand the concepts in order to master these concepts. So let's look at number 1. It says find f of 2. So f of 2, or evaluating f of 2. So this is function notation. F of 2 represents an output when input is 2. So in this graph, input 2 is right here. And what is the output? Corresponding output quantity is, we can estimate here maybe 0.4. And if you wrote 0.5, 0.3, that is okay as well. Because we just want to make sure you understood the function notation here. And let's look at part B. For what value or values of x, if any, does f of x equal 3? So here they give us the output is 3. So output is 3 right here. And what x value, what input quantity will give us output quantity of 3? So here asking f of what value will give us 3? And we're looking for this value. In this case, x equals 4. Let's look at part C. What are the zeros, also known as roots, if any, for f? So here, when we say zeros, we're looking for y values. So this is asking what values of x will give us 0. And there could be multiple x, and this is also known as x-intercepts. So if you look at right here, if you look at the graph when x equals negative 4 right here in the green part, this is the point where when x equals negative 4, the y value is 0. So this is the answer. And we can sometimes, we can always represent a point using coordinate. So this could be next negative 4, comma 0. So this is an x-intercept because it intersects x-axis. So when we say zeros or roots, that is same thing as x-intercept. And we can have multiple x-intercepts as well. So in this case, we just happen to have only one x-intercept right here. Let's look at the next problem. Consider a function given by f of x equals x minus 2 over x plus 2 times x plus 4. So in this case, we have a function given in a fraction form. This is also known as rational function. So f of 3, again, we're just evaluating. So we're inputting 3 as a quantity, as an input quantity. So instead of x, we'll be putting 3. So 3 minus 2 over 3 plus 2, 3 plus 4. Then I have 1 over 5 times 7 gives me 1 over 35. So when input is 3, output is 1 over 35. Now part B, now the input quantity is 3 plus h. So we have to input this entire thing as a quantity for x. So if you look at the given function right here, instead of x, we have to replace x with 3 plus h. So 3 plus h is the entire quantity. So let me write it out. So instead of x, I'm going to put parentheses 3 plus h minus 2 over 3 plus h plus 2 times 3 plus h plus 4, like this. So these are the input. Instead of x, 3 plus h is the input quantity. So let's simplify. We have in the top, we have 3 plus h minus 2. So we have 1 plus h. 3 minus 2 give us 1. And here at bottom, we have 5 plus h. And here we have 7 plus h. And we can leave it like this. We can also multiply the bottom part. But for now, we can just leave it as it is, because we're just making sure you understand that 3 plus h is input quantity. Now for part C, let's look at domain of this function. So again, here we have x minus 2, x plus 2 times x plus 4. So when we have a function given in fraction or rational function, and when we want to find a domain of a rational function, we want to look at top and bottom separately to identify what restrictions do we have. So we see what restrictions does x minus 2 give us in numerator. It does not give us any restriction. I can plug any number for x right here, and it will give me a number as an output, and it will be always defined. So x, the top part doesn't give us any restriction, so we don't have to consider x minus 2 when finding domain for this function. On the denominator, we know that we cannot have a 0 in the denominator. So having x equals negative 2 and x equals negative 4 will result 0 in the denominator. Therefore, we have to exclude these two numbers for the domain. So x cannot equal to negative 2, x cannot equal to negative 4. So let's write the answers in step-builder notation and interval notation. So for step-builder notation, it will be just x. This vertical line means x such that x cannot equal to negative 2, x cannot equal negative 4. So this bracket, this is a set of numbers, all the numbers except for negative 2 and negative 4. Now let's see how we can write this answer in interval notation. So I have a number line and mark negative 4 and negative 2. Here we have all the numbers, negative infinity, all the way up to negative 4, but excluding negative 4. That's why I put parentheses here. If we were to include negative 4, we'll put bracket. So also negative 4 all the way to negative 2, like this. So let's write one section at a time. This means negative infinity to negative 4, put parentheses, and we always put parentheses around infinity sign. Union means adding another interval, negative 4 to negative 2, union negative 2 to infinity. So let me highlight two answers. So this right here is answer in step-builder notation for domain of this function, and this is an interval notation for domain of this given function. We need to be able to express domain in both ways. So let's look at next problem. Another function notation problem. Oops. So here we have f of a. So here this line right here, this means we're estimating. So f of a is about 0.5. So f of a is about 0.5. Looking at graph right here. How about f of a plus h? So since this quantity right here is h, since this quantity is h, this point right here is a plus h. That means f of a plus h is, so let's just see the function value When input is a plus h, output is about 1.5. 1.5. Again, here we're estimating. Then let's look at part C. Part C is asking f of a plus h minus f of a. So when we evaluate something like this, we have to make sure we find each quantity first, then subtract from each other. So here we know this is 1.5, this is 1. So 1.5 minus 1 is 0.5. But again, because we estimate each of these, that's why we use this line, this symbol to estimate. So this answer also is an estimate. But the purpose of this problem is to make sure you can find the output given input in graph. So reading a graph using input quantity and output quantity. And this value right here, 0.5, refers to, I made a mistake. FA is actually 0.5, right? Hope you guys caught that. This is actually 0.5, so this is 1. So this 1 right here is actually this height right here. And that's what we found. Let's look at next problem. So another graph reading problem. An object is moving away from the math building according to the graph below. How long does it take the object to be 3,000 feet away from the math building? So this is time. I know it's kind of small, so I zoomed in the graph. But here, time since starting minutes. And distance from the math building is 1,000 feet. So 1,000 feet, 2,000 feet, 3,000 feet. So what is the corresponding time for 3,000 feet? 5 minutes. So when x equals 5 minutes, the distance, we're 3,000 feet away. So x equals 5 is the answer. So it takes 5 minutes to be 3,000 feet away from the math building. Okay, so let's look at more problems finding domain. We're going to look at one at a time. So A is actually quite simple, so I'm going to just do it right here. A, we have x squared plus 4x minus 2. Again, when we find a function, domain of a function given an equation, so here we have a function given an equation. The first thing we think about is what values can we not have? But here we can plug any numbers for x, and it will always give us a number. So this does not have any restrictions. So domain D is actually negative infinity to positive infinity. We can also say all real numbers. All real numbers. So in this case, there's no restriction, so we don't have to worry about excluding any numbers. So now let's look at part B. We have 2x over x squared minus x minus 6. So now we have a function in fraction form, and we know in fraction we cannot have 0 in the denominator. So essentially we want to find what value of x will make 0 in the denominator. In order to do that, we need to factor this. We have x minus 3 times x plus 2 if I factor this. And still build a habit of examining both top and bottom functions when we find restrictions for the domain. So again, here we can plug anything, so we're good for the numerator. But denominator, we cannot have x equals 3, we cannot have x equals negative 2. So final answer of domain for this function in self-Bedell notation, x such that x not equals 3, x not equals negative 2. And into notation, again, I suggest you draw a number line so that we will not miss any sections. So we have negative infinity to negative 2, negative 2 to 3, 3 to positive infinity. So negative infinity to negative 2, union, negative 2 to 3, 3 to positive infinity. So these two, okay, they mean the same thing, just different way of writing the answers. So these are the domain of this function 2x over x squared minus 6. Let's look at part C, and I'm going to write part C here again. What's it, x plus 3? So part C says x plus 3 to the half power. Half power is same as square root of x plus 3. Now here we have to look at what can we not have. What values of x will make it undefined. Then we have to look at square root. We know that under square root, we can only have either 0 or positive. So that means that whatever inside here must be greater or equal to 0. That means x plus 3 must be greater or equal to 0. Then we subtract 3 both sides. We get x has to be greater than equal to negative 3. So for set the notation of the domain, so capital D means domain, x such that greater than equal to negative 3. And number notation, interval notation, put negative 3. Now it's greater or equal. So that means we put bracket, means we include negative 3. And anything bigger than negative 3. So go forever to infinity. So we have negative 3 comma positive infinity. But here we put bracket because we include negative 3 in this case. So these two represents domain of this function. Now let's look at part D. So let me rewrite it. I have square root of 2x over square root of x squared minus 16. So part D, square root of 2x, square root of, what was it, x squared minus 16. Square root of x squared minus 16. So here again, we have to look at top and bottom separately. What restrictions do we have? So although this is a numerator, we cannot have 0. We cannot have anything less than 0 under square root, under the radical. So we know that 2x must be greater or equal to 0. That means that x must be greater than equal to 0. So that's the one restriction that we get from the numerator. Denominator is similar because we also have x squared minus 16 under the radical. But here, the difference is that it's not the numerator. So it actually cannot equal to 0. That means that x squared minus 16 must be strictly greater than 0. This is important because square root of x squared minus 16 is on the denominator of the function. So this cannot have 0. So square root itself is okay to have 0, but because entire thing is on the denominator, we have to have greater than 0. And we cannot have negative number after taking square root. That's why it's greater than. So then x squared must be greater than 16. And what are the cases when x squared is greater than 16? We have x greater than 4 or x less than negative 4. Because if I take square root of negative 5, for example, negative 5 times negative 5 gives me positive 25, which is greater than 16. So we have to consider both cases. So for a problem like this, we really should draw a number line. And let's consider all the cases. So we have this one, and this one. So let me mark 0, negative 4, positive 4. So let's mark less than negative 4. So all these, but also greater than 4. But the numerator tells us that x actually has to be greater than or equal to 0 only. So we cannot have this part. We cannot have negative 4 part here. This is not part of domain. Although negative 5 will be okay for the denominator, it will not be okay for the numerator, because it will give us square root of negative 10, for example, if x is negative 5. And let me also mark this on the number line. X greater than or equal to negative 5 right this way. But if you see, this is the only part in common. So our answer in interval notation is 4 to positive infinity. And in separate notation, we can write x such that x is greater than 4. So for these cases, we will have to think about all the restrictions we get. So although these two works for denominator, we have to find the range of numbers that works for both numerator and denominator. And x greater than 4 is only one that works for both numerator and denominator. They will have a number and that have a defined number. So not negative under the square root. So let's look at number 6. This is find the composite function. So here we want to find f composite g. That means f of g of x. So that means instead of input x, I'm plugging in entire g of x as an input. So let me highlight it. Instead of x right here, I'm plugging in g of x. So I'm just going to write negative 3 times g of x plus 1 over g of x, like this. So right here, instead of x, I wrote g of x, because g of x is input now for this function. So then we can replace g of x with the given equation for g of x. So negative 3, put parenthesis, plus 1, and in parentheses we put x squared plus 2. We write x squared plus 2 on the denominator as well. And let's just simplify a little bit. The numerator, we distribute this. Then we get negative 3x squared minus 5 over x squared plus 1. So this is f of g of x. And keep in mind, f g of x is not always equal to g of f of x. So this is not necessarily always the same as this. Sometimes they might be equal, but not always. So let's find inverse of each functions. Number 7. So part A, f of x equals 4 over 2 minus x. So there are a lot going on in inverse function. Remember, in inverse function, we're inverting the function process. So domain and range are switched in inverse functions. So I want to find another function that domain and range is switched from this function right here, part A function. So we can write f of x as y equals 4 over 2 minus x. And here we switch x and y. And in order to be more precise, we can just replace y with x. So let me write different color here. We write y with x and all the x's with y. Here we have to have only one x, so we just write it like this. Now we solve for this y right here. So in order to do that, we need to be able to view this 2 minus y as a one quantity. So I'm going to multiply 2 minus y both sides, like this, so that I can cancel this out. Then I have 2 minus y times x equals 4. Again, our goal is to isolate y. So in order to do that, we multiply x. So then I get 2x minus xy equals 4. So let me actually bring this right here. 2x minus xy equals 4. Again, our goal is to isolate y. That means I'm going to subtract 2x both sides. Then I have left with negative xy equals 4 minus 2x. And last step, we're going to divide negative x both sides. Then y equals 4 minus 2x over negative x. And here's a really important last step that is easy to forget. We must replace this y with f inverse sign. Otherwise, we're saying we have two different y's here. We're just using y for time being. So we write f inverse of x equals 4 minus 2x over negative x. So this is the inverse function of this function right here. And as we talked about, you can actually verify that these are inverse functions by composing them. F of f inverse, if you do this composition, you should get x if everything's correct. And also f inverse of f of x also should give us x as well. So we can verify that these are indeed actually inverse to each other. And I also want to note that f inverse is not 1 over f. This is important. They're not same thing. Okay. So let's look at part B. Another problem of finding inverse. Oops. So this is part B. So here again, we write y instead of f of x. And x, we switch, because we're switching domain and range, that's why x we write, instead of y, we write x. And for all the x's, we write y. This. Again, our goal is to isolate y. So first, we multiply y plus 3 both sides. These cancel out, so let me write it. We have y plus 3 x equals 2y. And here we're going to multiply x, distribute x. So xy plus 3x equals 2y. Since our goal is to isolate y, that's what it means to solve for y, we're going to put all the y's in one side of equal sign and all the terms without y in the other side. So that means one way we can do that is just subtract xy both sides. Then let me write this step right here. Then I have left with 3x equals 2y minus xy. Again, our goal is to isolate y. Now since each term has y on the right side of equal sign, I can actually factor out y here. Then I get 2 minus x, and on the left side we have 3x. So then in order to solve for y, since they're multiplying y times 2 minus x, I just need to divide by 2 minus x both sides. So we have y equals 3x over 2 minus x. And again, one last important step, we need to write this as f inverse of x equals 3x over 2 minus x. So this function is inverse function of this function right here. And if you composite them, we can simplify to x. Okay, so let's look at last one. Let me x cubed plus 8. Part C, we have x cubed plus 8 as f of x. Let me write it better. So similarly, we write y equals x cubed plus 8. And again, we can replace y with x with y. We're solving for y, so subtract 8 both sides. So x minus 8 equals x cubed. Now how do we undo to the third power? We can take the cube root both sides. So we take the cube root both sides. So then we have y equals cube root of x minus 3. So y equals cube root of x minus 3. But then one last step, we have to write f inverse of x equal cube root of x minus 3. So this is the inverse function of this given function right here.